Electrical safety is of paramount importance for anyone working with or around electrical systems. Whether you are a seasoned professional or a do-it-yourself enthusiast, understanding the potential hazards and implementing appropriate safety measures is crucial to prevent accidents, injuries, and even fatalities. Electricity, while essential to modern life, can be extremely dangerous if not handled properly. A fundamental aspect of electrical safety is understanding the nature of electricity itself. Electricity is the flow of electric charge through a conductor. This flow is driven by a voltage difference, often described as electrical potential. The higher the voltage, the greater the potential for electrical current to flow. When electric current passes through a human body, it can cause a range of effects, from mild shocks to severe burns, cardiac arrest, and death. The severity of the shock depends on several factors, including the amount of current, the path the current takes through the body, and the duration of the exposure. One of the primary hazards associated with electricity is electric shock. Electric shock occurs when a person comes into contact with an energized conductor and a path to ground. This can happen in a variety of ways, such as touching a bare wire, coming into contact with a faulty appliance, or working on electrical equipment without properly disconnecting the power supply. The effects of electric shock can range from a tingling sensation to muscle contractions, difficulty breathing, ventricular fibrillation, and cardiac arrest. Even a seemingly minor shock can cause serious internal damage. Another significant hazard is arc flash. An arc flash is a dangerous electrical explosion that occurs when a high voltage discharge jumps across a gap between conductors. This can happen when there is a fault in the electrical system, such as a short circuit or insulation breakdown. Arc flashes generate intense heat, pressure waves, and loud noises, and they can cause severe burns, blindness, hearing loss, and other injuries. The temperature of an arc flash can reach up to 35,000 degrees Fahrenheit, which is hotter than the surface of the sun. Arc flashes can also ignite flammable materials in the vicinity, leading to fires and explosions. Electrical fires are another serious concern. Electrical fires can be caused by a variety of factors, including faulty wiring, overloaded circuits, and malfunctioning appliances. These fires can spread rapidly and are often difficult to extinguish, as water can conduct electricity and exacerbate the problem. It is essential to use the correct type of fire extinguisher for electrical fires, such as a Class C extinguisher, which is designed for use on electrical equipment. Grounding is a critical safety measure that helps to protect against electric shock. Grounding provides a low-resistance path for fault current to flow back to the source, which can trip a circuit breaker or fuse and energize the circuit. This helps to prevent the voltage from building up on metal parts of electrical equipment, which could pose a shock hazard. All electrical equipment should be properly grounded according to the National Electrical Code, or NEC. Ground fault circuit interrupters, or GFCIs, are another important safety device. GFCIs are designed to detect even small amounts of current leakage to ground and quickly interrupt the circuit. They are particularly effective in preventing electric shock in wet or damp locations such as bathrooms, kitchens, and outdoor areas. GFCIs are required by the NEC in many locations where there is a high risk of electric shock. Lockout/tagout procedures are essential for working on electrical equipment safely. Lockout/tagout involves disconnecting the power supply to the equipment and placing a lock and tag on the disconnect switch to prevent it from being accidentally re-energized. This ensures that the equipment remains energized while work is being performed, protecting workers from electric shock and other hazards. Personal protective equipment, or PPE, is also important for electrical safety. PPE includes items such as rubber gloves, insulated tools, and arc-rated clothing. Rubber gloves provide insulation against electric shock, while insulated tools prevent current from flowing through the body. Arc-rated clothing protects against burns from arc flashes. The type of PPE required depends on the specific hazards present. Safe work practices are also essential for electrical safety. These practices include always de-energizing equipment before working on it, using the correct tools for the job, and keeping a safe distance from energized conductors. It is also important to be aware of the potential hazards in the work area and to take steps to mitigate those hazards. Regular inspection and maintenance of electrical equipment is crucial for preventing electrical accidents. This includes checking for damaged wiring, loose connections, and other signs of wear and tear. Any problems should be repaired promptly by a qualified electrician. Education and training are also essential for electrical safety. Workers should be trained on the hazards of electricity and the proper safety procedures to follow. They should also be trained on the use of PPE and other safety equipment. Do-it-yourselfers should also educate themselves on electrical safety before attempting any electrical work. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical safety. The NEC covers a wide range of topics, including wiring methods, grounding, overcurrent protection, and equipment installation. Compliance with the NEC is essential for ensuring the safety of electrical installations. Firstly, always assume that electrical circuits are energized unless proven otherwise. Secondly, use a voltage tester to verify that the circuit is de-energized before working on it. Thirdly, never work on electrical equipment in wet or damp conditions. Fourthly, keep a safe distance from overhead power lines. Fifthly, do not overload electrical circuits. Sixthly, use extension cords safely. Seventhly, replace damaged or frayed cords immediately. Eighthly, install and maintain smoke detectors and carbon monoxide detectors. Ninthly, have a qualified electrician inspect your electrical system regularly. Tenthly, know the location of the main electrical disconnect switch in your home or building. The NEC Article 90. 1 outlines the purpose and scope of the code. It is intended for the practical safeguarding of persons and property from hazards arising from the use of electricity. The NEC contains requirements for electrical installations in buildings and other structures, including residential, commercial, and industrial facilities. It covers a wide range of electrical systems, including wiring, overcurrent protection, grounding, and equipment. The NEC is updated every 3 years to reflect the latest technological advancements and safety practices. Compliance with the NEC is essential for ensuring the safety of electrical installations. Overcurrent protection is a critical aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current flow. When an overcurrent occurs, the circuit breaker or fuse will trip, interrupting the circuit and preventing damage to equipment and wiring. The NEC specifies the required overcurrent protection for different types of circuits and equipment. Grounding and bonding are essential for electrical safety. Grounding provides a low-resistance path for fault current to flow back to the source, while bonding ensures that all metal parts of electrical equipment are electrically connected. This helps to prevent the voltage from building up on metal parts, which could pose a shock hazard. The NEC contains detailed requirements for grounding and bonding. Wiring methods are also an important consideration for electrical safety. The NEC specifies the approved wiring methods for different types of installations. These methods include conduit, cable, and other wiring systems. The wiring method must be appropriate for the environment and the type of occupancy. Equipment installation is another critical aspect of electrical safety. The NEC contains requirements for the installation of various types of electrical equipment, including lighting fixtures, receptacles, and appliances. The equipment must be installed in accordance with the manufacturer's instructions and the requirements of the NEC. Electrical safety in the workplace is regulated by the Occupational Safety and Health Administration, or OSHA. OSHA requires employers to provide a safe workplace for their employees and to comply with all applicable electrical safety standards. OSHA also requires employers to train their employees on the hazards of electricity and the proper safety procedures to follow. Electrical safety is a shared responsibility. Everyone who works with or around electricity has a responsibility to follow safe practices and to be aware of the potential hazards. By understanding the principles of electrical safety and implementing appropriate safety measures, we can help to prevent electrical accidents and injuries. Firstly, never attempt to repair electrical equipment unless you are qualified to do so. Secondly, always disconnect the power supply before working on electrical equipment. Thirdly, use the correct tools for the job. Fourthly, wear appropriate personal protective equipment or PPE. Fifthly, follow all applicable electrical safety standards. Sixthly, be aware of the potential hazards in the work area. Seventhly, take steps to mitigate those hazards. Eighthly, report any electrical hazards to your supervisor. Ninthly, participate in electrical safety training. Tenthly, promote electrical safety in the workplace. Electrical safety in the home is also important. Many electrical accidents occur in the home each year. These accidents can be prevented by following safe practices and being aware of the potential hazards. Firstly, install ground fault circuit interrupters, or GFCIs, in bathrooms, kitchens, and outdoor areas. Secondly, use extension cords safely. Thirdly, replace damaged or frayed cords immediately. Fourthly, do not overload electrical circuits. Fifthly, keep electrical appliances away from water. Sixthly, teach children about electrical safety. Seventhly, have a qualified electrician inspect your electrical system regularly. Eighthly, install and maintain smoke detectors and carbon monoxide detectors. Ninthly, know the location of the main electrical disconnect switch in your home. Tenthly, be aware of the potential hazards of electricity and take steps to mitigate those hazards. Understanding basic electrical concepts is essential for promoting electrical safety. Knowing the difference between voltage, current, and resistance is crucial for understanding how electricity works and how it can be dangerous. Voltage is the electrical potential difference between 2 points. It is measured in volts. Current is the flow of electric charge. It is measured in amps. Resistance is the opposition to the flow of electric charge. It is measured in ohms. Ohm's law states that voltage equals current times resistance, or volts equals amps times ohms. Understanding Ohm's law is essential for understanding how electrical circuits work. Electrical circuits can be either series or parallel. In a series circuit, the current flows through all of the components in the circuit in a single path. In a parallel circuit, the current has multiple paths to flow through. The total resistance of a series circuit is the sum of the resistances of all of the components in the circuit. The total resistance of a parallel circuit is less than the resistance of the smallest resistor in the circuit. Understanding the difference between series and parallel circuits is important for troubleshooting electrical problems. Electrical safety is a continuous process. It requires ongoing education, training, and awareness. By following safe practices and being aware of the potential hazards, we can help to prevent electrical accidents and injuries. Remember, electricity is a powerful force that can be dangerous if not handled properly. Always exercise caution when working with or around electricity. The information provided here is intended for general knowledge and informational purposes only and does not constitute professional advice. It is essential to consult with a qualified electrician or other professional for specific advice related to your situation. Always follow all applicable electrical codes and safety standards. Working with electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm.